So whether you develop AI applications or not, so far you would have heard the name MCP servers. So what are they? Are they some AI thing which you can use in AI apps only? Or if you are already an AI developer, is it a function calling feature provided by various LLMs in some better format? Let us try to find out. In this video, we will understand what MCP protocol is. We will use FastMCP Python package to develop simple examples whether MCP is really a AI thing or it is a function calling version 2.0 or what it is. So in this video, we will create something like this. We will instantiate a MCP server and we will create three simple clients. Simple MCP client, MCP client with AI capabilities, and again the function calling. Function calling, by that I mean if you are a AI application developer, you might have used this function calling feature provided by various LLMs. For example, GPT models support this, where a user input comes in and you can literally map that user input to certain functions. For example, if somebody want to know what is the weather in London right now, so from your provided tools, from your provided set of functions, LLM can identify which function to call. By the way, that is very much function calling specific, but in this video our focus is going to be on the MCP server and understanding this, what it is all about. Let us have a look into the MCP server first. So in this project I have created a module called MCP server itself. Let me close the already running server. This have exit now. So MCP server, as I said, I am using this FastMCP Python package to develop those servers and clients. So this is quite simple, and this is one of the implementations of MCP or Model Context Protocol. Please note, MCP is a protocol and various libraries implements that. So here to run these examples in this project, you need three dependencies. So let us get back to MCP server. The most important thing in MCP server is its tools. Very much like in REST server where you have endpoints, in MCP server you have various tools and sometimes more than tools as well. If you go to the Model Context Protocol website, you will find three types of facilities your MCP server can expose to your clients. First of all, and most used thing is tools. In these examples, these are just functions which can do very simple or very complex things as well. Resources, these are passive or static data. It could be in form of text files, markdown files, or databases, for example, or any data which exists on your disk locally or in your some file system, so things like that. And prompts, yeah, if you are using various or a number of prompts in your AI application, then you can also store them in your MCP server and you can get them whenever you need. You can identify them by name or some ID, so things like that. We are going to see it in a moment. So this is how a server looks like. So similar thing in our MCP server, for example, there are various MCP tools. And how do you define a tool? With simple decorator. That's all you need to do to define a MCP tool. These tools are very simple in our example, but they can be very complex, or they can contain any kind of business logic if you want to put inside. So these are tools, very simple tools like calculate. It will do some add, subtract, basic mathematic operations. One more tool to get user information. Then we have resources. So these are again functions with a different decorator like MCP resource. It has got a URL. So in this video we are not really going into how to use resources and prompts, but our purpose in this video is to understand what MCP is all about and how it differs to function calling. Similarly, at the bottom you will see some prompts are also defined with this simple decorator. So these are the toolings, resources and prompts available in my MCP server, And if you want to start your MCP server, one line, this you need to define or instantiate your MCP server with, and then at the very bottom I would be calling some start or some method like that. So yeah, before moving forward, we will have to really understand what are the modes or what are the interfaces MCP server provides its client to connect. For example, here are 4 types of modes or transport modes, to be specific, provided by this FastMCP library or Python package. It could be different from package to package. As I said, model context protocol is a protocol, and there are various implementations done by various people. So in this library, I have SSE, server sent events, and you can also connect to MCP server via HTTP and streamable HTTP as well. This standard IO is a special mode where your server and client are running in a same memory space. Let us say, means client can directly access your MCP server.py, and you can use this module directly into your client to speak to your MCP server. We will have a look into the client code in a moment. So the default transport mode for my example, I'm using SSE, and when it is selected, it will just start my MCP server here. So here is the start MCP server function, which takes transport mode, host, port, and force restart. If you provide force restart to true, it will basically kill the already running server first and then will start. Otherwise, port already in use, such kind of error you will face if you don't do a force restart, for example. So this is a very simple MCP server code. Of course, there is no security authentication types of things are not done here for the sake of keeping the demo very simple. And yes, to start the MCP server, what you need to do is just you need to run this Python file, and the server will be running immediately on the defined port. And yes, before running the server, make sure that you have installed all those 3 dependencies. Now next, let us move to our first client, that is the simple MCP client. Let us have a look what's happening inside it. Please note, my server is already running in background, and I will run my client as well, and I will show you what is going on inside the client, what are the variable values when we run it using the debug mode. So this is our client. So you see those lines, the commented lines, where I have demonstrated how to connect to your MCP server based on the transport mode it has exposed. In our case, of course, it is SSE, server sent events. But if it is something else, for example, HTTP, so you will instantiate your client like this. In case of streamable HTTP, like this. And as I said, in case of standard input output, this is not the remote way of connecting to your MCP server, but you can directly include your MCP server.python into your client object, and it will get the things done. So except standard IO, all are those remote methods where your client can connect to your MCP server remotely. So let us start our simple MCP client in debug mode so that we can see what's happening inside the client and we can read various variables. So let me start my simple client in debug mode, and here we are starting it. So control has reached here. You see this client object. This again is created using FastMCP Python package or library, whatever you want to call it. And it has got all the APIs to instantiate your MCP server as well as client. So it has got a nice method called ping. Let us proceed with the control flow, and we see the value of the ping result is true, so that it indicates that we can speak to our MCP server. And if we go further, now this FastMCP client has got several methods. As you can already see, ping is connected, and this is connected method, what it is going to return you should be pretty clear whether you are connected to your MCP server or not. If I take further, there are more methods to your FastMCP client. For example, this is very important, list tools. it will give you the list of all the tools served by your MCP server. For example, here we have defined that many tools, and I am speaking only about tools, not resources and prompts. There are different methods for the resources and prompts to get the list of them. So if I take the control further, then it will tell you that there are 3 tools available, and if you really want to know the details of the tools, you can call the properties or methods on the top of those objects. So this tool is an object which is returned by your MCP server, and it has got several properties. If you really want to know what all properties are available in your MCP tools, you can expand here in debug mode, and I will try to show you. For example, this get weather tool, we had it in our MCP server, right? So let me take you there, get weather. And what is the documentation? By the way, this title is a field which is automatically defined by FastMCP to give it more user-friendly names. It happens to the input parameters as well, but in this case it hasn't. But you can manually assign a title to this method as well. The important thing is the name and description, and then you will have more properties like input schema. What is the input this tool is going to have? What are the parameters of this method? City. Here FastMCP assigned this title city. It made it caps. That's it. That's pretty much of it. And the type of this input parameter. So this is about input, and there are more properties in this tool object. Of course, the name and output. What kind of output and what is the type of the output this tool is going to produce. So back to our simple MCP client. So just by calling this function, you got lots of information out of your MCP server. Now think about the REST way of doing, how you call your functions or endpoints from your REST server. You will have to know the documentation of your endpoints first of all. Of course, you can have the Swagger-like documentation tools implemented for your server, but if you don't have, imagine how difficult it is going to get the documentation. Here you get the full documentation. We can create a full dictionary out of it if you really want to see it in textual format, or you can print literally the tools by wrapping it or casting it to a string type of object. If we go next, the similar thing you can do with the resources as well. List resources, all the resources with their properties, documentation, and everything. Input parameters will be listed for you, and nothing different for prompt as well. You get some prompts defined in your MCP server, and maybe it is following a Jinja template and you want some variables to be replaced in your template. You can provide arguments to your prompts, and those arguments will replace your variables in your template. If we go further, here it is basically typing more, printing more information from the tools it has received. If I expand the console, so basically this is the input schema I was showing you here, and this has printed it for you for better understanding. So you have the full MCP server tool schema here, and if you really want to call a tool, if I take the control further, it will run this loop for 3 times. So this is call tool function, very simple call, and you give it the tool name and the parameters. That's it. You really need not to create a Python function out of these strings. That's all the job of MCP server. It minimizes that effort. If you have done any kind of function calling for your AI app, you could have understand. First, LLM will reply you with some suggested functions and its parameters. Then it's your job inside your application. You will have to write some logic to make those strings to really a function-like thing, and which you can call actually. So all that pain has been taken away by MCP server, and You just call this function and you will be having your results with you. Where the result, this is your data, temperature, condition, and then you can parse this dictionary or pass this result to another application, another function, whatever you want to call. So it's that easy actually. You instantiated a client, then you have a lots of functions to discover what's the capability of your MCP server to call those tools, resources, prompts out of the MCP server. And by this time, there is no AI I have shown or I have implemented for this simple client. It's pretty much looking like another remote procedure call framework. And it is like that. That's pretty much all about the MCP server. Now moving to the next client implementation, that is AI MCP client. So what we did here is we discovered basically by list tools, list resource, list prompt functions, and then we called one of the tools manually by typing in the code. But when we say AI MCP client, it's nothing different. We will put an AI layer on the top of this whole MCP tool calling, and that's it. User will provide input, for example, get me the weather of London, and along with that we will provide the full list of tools to LLM, and then LLM can map user query to the list of tools provided, and it will return you with the tools it suggests or it found to be most matching to your user query. That's pretty much of it. Let's have a quick look into the AI MCP client as well. So let me stop the debugging of the simple client. I will start debugging of this AI MCP client now. So this is a user request. So for the demo sake, I kept the application very simple. So this is a fixed set of 3 user inputs. What's the weather like in Tokyo? Calculate this 25 divided by 5 and get information for user ID 2. These 3 tools I'm having. I'm not speaking much about resources and prompts, but to understand the MCP concept, this is quite enough, I believe. So it will iterate through all these user requests. So how it is doing is here. So it has defined a prompt by itself. By the way, this prompt you could have defined in MCP server as well. But to make it more simple and easy to correlate with your AI app development before MCP, you have a prompt and you a Jinja template basically, and you provide it with some additional information. So this is very important. This tool string. Along with prompt, you need to provide the tools available in your MCP server. So how simple it is. You just got the tools. How did we got the tools here? Just by list tools, and you just need to pass the string format of those tools. If I show you what is inside the tools, you will be able to correlate. For example, this is like this. The string format would be pretty much the dictionary conversion of these strings. Those strings will get converted to a dictionary, and this you can simply send to LLM. You need not to transform it to like what is your tool name, then parameter, their type. You really need not to do any conversion. So that's exactly what I'm doing here. I am just taking this array of tools which is returned by this function called list tools, and at max I'm just calling, or I'm just casting every tool to its string form, and out of that I'm creating array. This line just creates an array, and you forward that array to your LLM with the prompt and of course the user input. Of course the prompt itself does something like you really need to find out the correct MCP tool or something like that. You can write it in there with some examples like given here. So this prompt is pretty much complete with user input and tools string. Now again, I would like to mention, if you have done any kind of function calling in your AI app, just imagine, just to create this dictionary or this array of dictionaries, you will have to first read all the functions, then you will have to get the description, Then you will have to get the parameters, what they are and what is the type, and even to make your call with LLM more efficient so that LLM can identify your function pretty well, you might need to forward the return type and exceptions being thrown by that function. And that logic to create your tool description, you will have to write it yourself. But here you need not to do anything. You just converted your tools list directly coming from MCP server to string, and that's it. That I have passed here. Let us go further. And at the end, what I'm doing is this. I am just sending my request to LLM. I'm using Grok with this model. This is a message like I'm a user and I'm sending this prompt to you. The prompt is pretty much what we have created. This is a whole tool list converted to string that is being sent to LLM. Now you can of course do some filtering using RAG-like things so that you need not to send lots of data to LLM to reduce the token counts. But we have only 3 tools which LLM want to process, so it is okay in our case. But generally you put some kind of filtering before sending to LLMs. So yes, so all the tools with prompt goes to LLM, and then we receive LLM response. And what is in the response is being printed here. I will go further. So now LLM has identified. So the user request was the first user request in the array. We created an array of 3 requests here. What is the weather in Tokyo like? So what did it do is AI selected get weather function. So out of 3 tools, it has identified the correct tool, and with parameter it has also correctly identified Tokyo. That's it. Now you have the tool name. So that is the most important thing you need. What you will do is you will simply say MCP client, go and call this tool on my MCP server. Your MCP client is already connected to your server, so it will get the things done with tool name and parameters identified. That's so simple. That's why I would call MCP to be a function calling version 2, because it makes your function calling so easy. Again, as I have said, when sending your request to LLM, you will have to create the tools description and everything in form of JSON yourself. You need not to do it in case of MCP. And similarly, as soon as you get the LLM response that which tools or function should be called for this user input, if you are not using MCP, then you will have to prepare a function call yourself once again. But here you need not to. You just need to know the tool name and parameters, and everything will be taken care by MCP server itself. So that's how this AI MCP client is working. Pretty simple, nothing new. Now at the end, let us have a look how the legacy function calling has been working. Let me stop the debugging of this AI MCP client. I will start debugging of this function calling client. So here I have defined the new functions for function calling demo. Although it is not necessary, you can directly call those functions or can use those functions as a part of your function calling implementation. These annotations will be totally ignored in that case, because function calling is literally function calling. You just need a definition of any function, that's it. But I have defined it once again here. What you need to create is, what I'm doing here is creating a map just named to the function object itself. Then what we are doing is the heaviest thing, get function signature and the doc string. That's what I have been speaking about. This whole dictionary you will have to prepare yourself. Take out the name of the function, read the documentation of the function, read the parameters and their description, read the parameter types, exception if that function throws any, and return what your function returns. That all this full from here to here, this schema which we are preparing was done in single line in case of MCP server. Let's have a look here again. What I was doing is tool names here, these tools, this single line. These tool objects were created simply to string, to be specific, a JSON form or dictionary. Here you will have to prepare that yourself, because now these are not MCP tools, these are your tools. So which we have done now, and 3 times it will call because 3 functions are there. Then the schema which we have prepared is what is the type of my tool, then the name, the description. It's pretty much the same thing, but the difference is we were to create it ourselves. So that is the pain you will have to face when doing function calling. Now as you do in your function calling, rest of the things are same. You have a user request, pretty much like our AI MCP client demo, and then along with the user request in your prompt, you will this time send this schema which you have just prepared yourself by writing your own logic. So here is my prompt, the function schema. I'm creating a JSON out of it and user input, and this call is exactly the same thing. And again, once your LLM has responded, the same thing you will have to do once more. You created a JSON schema yourself out of your tools, and when you have received your LLM response, this time you will have to convert the LLM response into actual function calling, actual Python function calling. That's another pain. Now this is your LLM response. Let us have a look. It has got write function, that's good, and write parameter as well. Now we are taking out the function name and parameters. So what we did in case of MCP, AI MCP client, when we were using, or in case of any MCP client, we just directly called that function. We directly called that tool, one line only. But here you will have to prepare that call. So here we are preparing our function call in those many lines. Single line did the job in case of MCP client. There are certainly benefits of using MCP in your AI or non-AI project. When I say non-AI, I mean, are we really speaking about MCP to replace REST-like RPC frameworks? But is MCP really going to replace other RPC frameworks or protocols like REST or any other? It would be really early to say. I'm speaking about in non-AI applications. But for your AI applications, MCP is really very helpful. As we have seen, it reduces lots of code from your applications, makes your tooling more manageable, scalable, and less messy. Let us say it like this. But do you really opt for MCP server right now in your AI application? It is about analysis. If your AI application is to scale, where it will have to speak to more tools, then your MCP server can help you. But if you are sure that I have a fixed set of tools or not rapidly increasing set of tools, and you have already working function calling logic in your application, in that case moving to MCP server is not a good idea, because at the end you will have to run something. And then in this demo we haven't catered the authentication and security aspects of it. Then in that case you will have to take care of that. I hope you find the video informative. Thanks for watching.